Okay. I did a derivation and it looked wrong. And then I asked O1 Preview, the PhD problem solver, according to other people, to find my error. And it said things I don't want to even talk about anymore. But okay, I already cancelled my subscription, so I went to Claude AI, asked that to find my error. That's like half an hour ago. I'm still mad. So, well, yeah, I closed all my AI tabs. I'm not going to do anything with an AI anymore for the next 10 years or so. I still need to find the error that I have, however. So let's just have a look at Discord. I think that the way I can do this is layer, I mean, on my top, so. I think I'm just going to test my derivation by checking every equation. So let's say you have the E, which is 0.006. Okay, small enough. And then we need some other constants like this A here. AG. I'm so pissed off now. I went to Claude AI to ask a question. Yeah, it said this. So I asked it to find the error that I made, and it says, "Oh, I found your error. The error is here. When moving C3 squared up from denominator to multiply everything inside parentheses, the first term should have become minus or plus C1 times C2 divided by C3 times C3 squared is minus or plus C1 times C2 times C3, not minus or plus C1 times C2 times C3. So yeah, no new subscription for Claude, but it just infuriates me. How can people hype this up? Why are they paying for it? This is worse than Eliza was 50 years ago. I mean, fuck me. Really, I'm completely disgusted. I do not want to have anything to do anymore with those AIs. Plus, I asked you in Discord to find my error. You didn't reply, I think. Did you? No. Yeah. Where did I make the error? That was hours ago. But okay, I'll do it now. So I'm gonna find some A. That doesn't all matter. Anything would work, I guess. Oh wait, actually A should be pretty small. B could be, let's take a negative number, 3.2, double const. Okay, C is, I don't know, 1. Now maybe 1 is too confusing. Let's make it more or less 1. Yeah, the only way I can do this, I think, is when I can either make, I still have to make x symbolic, or I mean, normally I would just check this again and again and again. But now I'm going to assume that I'm too stupid, that there's a typo here and that I can't find it. And the way I want to find it now is, well, I guess you can just test it for 4 different x values. I mean, if it is equal for 4 different x values, then it must be correct at the coefficient level, right? Because a cubic, no, actually five values. You can have 2 points for a line, 3 points for a parabola, 4 points for a cubic. So it is 4. Well, 4 or more. Just test some x values. That should work. We're going to do this the most pathetic way. I want to read this one. This guy seems to agree with me. Our whole organization is currently not subscribed to any model. For the first time in years. I didn't know it already existed years. We are in a very bad place right now with the SOTALLM chat providers like Claude. Claude is just not up to the task of being used for work. The limits are far too constrained, or we're not particularly impressed with the latest iterations. The placeholders being forced into code is also a big issue for us. Now, for me, it's more it's just the plain stupidity of it. He's just talking about constraints and limits and stuff. Yay, someone who agreed with me. Let's see how many downvotes I have. No, none. Nobody downvoted it. Okay, plop. Or probably the same number of upvotes and downvotes. Okay, so double x return 3 new messages. I can't read that, I'm here. X minus e times c plus b times x. And you have these lamers that say that it is my fault. Yeah. It's always, as soon as the AI makes an extremely stupid, gives an extremely stupid answer, then there is a whole bunch of people that say that that you prompted wrong. If you were a smart guy, you would have written the prompt differently, and then you would have gotten the correct answer. No, I don't think so. I don't think so. plus a times x times x. Ja, dat is zo. Now, do I have to copy that stuff? Those constants? I guess so. Just copy them. Hello, Kotaro. Okay, here's another one. Oh, it's also called px, but I want to check if they are equal. So let's call this one q then. Smiley double x. No, wait a minute. We were working on this one. Sorry. I just want to check if this is equal to that one. Let's call this then variant 1, variant 2. I'm still going to call it P. And this one is then minus C times that plus C minus B times E times X plus B minus A times X times E, times X times X plus A times X, that looks silly, times X times X times X. We should just use power. Okay. That is the first line. And in order to check if these two are the same, to check px1, px2. Some random number. So for each x value, if these functions are equal for all those x values, then their functions are equal, I'm going to say. Which in this case means that this equal sign is correct. Ta-da! I checked myself. No AI necessary. And for this we need to have C assert and Boolean almost equal, which is then two doubles, y1, y2. And initially I'm just going to print the difference to get a feel of how close these things are going to be. Oh, yeah. Yeah, okay. move this away now. Yes, it's a standard as well, I guess. You never know. What? It should be almost equal. Yeah, okay. It's also always equal at the moment. Okay, so these things are really small. For now, let's do 10 to the minus 12. I'm not sure if that's gonna hold, but correct. So these two are equal. No, next. Because I'm being paranoid now, I just want to check everything. Okay, let D have the same dimension unit as X, so that epsilon is E divided by D is dimensionless, because E has the dimension of X, as in per that, it's just the root of the function. So if D has the same dimension, then this is dimensionless. And well, I'm not sure if I need it or how I need it, but it's a formula, so we're going to type it in. Double epsilon is E divided by D. Unfortunately, I don't have a D. Well, eventually I'm going to define my D, so maybe I should just do that already. Where are we? Eventually I'm going to say D is this. Yeah, so I need my... Oh boy. I need these things first as well. Yeah, this was correct. So now we can set double const C0 is. So the C0 is the constant term of the polynomial, and I just checked this and I want it to be that. Therefore, that is the constant term. Yes. C1 is the same thing. C1 has to be this. Double const. That was plus, yes. Here again a plus. So the C2, the coefficient of x squared is equal to that. Double const. C3 is A. Then I'm going to set that D, going to set D equal to plus or minus in the end something. Is it not that decision not made somewhere? Actually, it doesn't matter what I set it to. Plus or minus should both work. Yeah, set it. I'll just set it to C2 divided by C3. I think that's enough to test just that. Later I can add a minus. So now we have an epsilon. Now here I just replaced E with d epsilon. So yeah, I mean, but let's check these. Okay, so check. Well, this is not a function of x, so I can just do almost equal. C0, comma minus C times d times epsilon. I'm gonna print epsilon here. Almost equal C1. That would be this one. Can't make any errors if I just copy paste it. Almost equal C2. That would be that. And almost exactly equal C3, comma A. This becomes a multiply. This becomes a multiply. And this becomes epsilon. Oh, wait a minute. It returns true if it is almost equal. So I must add asserts around it. So epsilon is really small, really small. And it did not assert, so this block is correct as well. Next, eliminate A, B, and C to end up with this equals 0. Yeah, which is actually trivial, but I can check it anyway. It's maybe a bit too trivial to check, or shall I just check everything? So assert almost equal, no, 0 is almost equal to, what was it? This thing. Can speed it up, I think. Substitute the dot with space, star space, and substitute epsilon. Yeah, the powers are a bit harder, I think. Yeah. Would have been nice if I could do all those substitutions automatically with one key press. Oh, I have to write a macro then. But this is not an exercise in Vim. I just do it a stupid way. You see, I make mistakes. Even at this level I make mistakes. But okay, I guess that if it doesn't assert, that it means double that I did not make a mistake, either by typing it in as well as deriving it. I mean, it's the chance on me making a mistake typing in the program that exactly cancels out the mistake that I made during the mathematical derivation is pretty small. So this works as well. Then we get what is that dimensionless? Since okay, so we said that, and I already did that. After neglecting the cubic term, we have this. So this should be pretty much correct. I mean, we already know that this is like 10 to the power minus 6, so yeah. But there's no real reason to check this, right? It is just the same as what we had, but then the cubic term away. Yeah, it's just the same thing. Well, I replace this d with this part, so that's where the plus or minus come from. And then here it's a square anyway, so no plus or minus, and this one is ignored, neglected. Now the question is, did I make a mistake here somewhere? Solving for epsilon. Well, now I'm trying to solve this cubic so that better holds. So I have to check this anyway. And I would preferably find an epsilon that is actually solving this quadratic, so I can use that here. Oh no, I just calculate the whole thing and then see if that epsilon is, yeah, yeah, that epsilon then should be the same as this epsilon. So what I can do is calculate this and then fill that into this equation, which then should be 0. Yeah. So I'm gonna check if a certain epsilon filled into this equation is 0, which means that I'm going to add a function called check epsilon, which then gets a double epsilon, and that must do an assert on the value of this thing to double your results. I really need a square. square. It might actually have to work for both signs, and I don't know. If one of them fails, I can think about it again, or just pick one sign here, plus or minus. And the result should be equal to 0 again. Cool. Let's see. This is C0 plus or minus C1 times C2 divided by C3 times epsilon, plus C2 times the square of C2 divided by C3 times epsilon square. And it must be 0. Double square, double x, turn x times x. So then you can do, well, for example, this one. Check epsilon, that thing. I'm starting to wish that I do have. What if that this plus or minus is linked to the plus or minus inside this function though? Where does it come from? This plus or minus comes from, that's like literally minus that one. That's how we solve it. So I have to put a loop here. Well, this should be minus that, yeah? So I'm just gonna do, yeah, I'll just choose 2.0 minus that here. This, however, is another plus or minus. Both should work. Someone invited me to chat on the Reddit. I don't think I have time for that now. I didn't even know that was possible. On the other hand, maybe it's a real developer of Anthropic. Okay, let's have a look. Now to find it back because I already closed it. Damn it. Yeah, this is kind of weird though. It's kind of weird. Someone inviting me to try out a platform for free. What is the right word here? It seems weird. Also, seems weird. To be able to switch between AIs that normally all cost I don't know, $20 per month. Get that for free. I guess you can put it here because there's nothing on it that people should not be able to see. Yeah, I help on this Prussian help. So this is more like me helping there, not not that I typed anything myself there. In the sense of I want to die or something. Let's see. So yeah, here. Okay. Okay, I'm removing this here. Sorry. Oh, that sucks. I'll just make it a lot though. So But look here, this is the epsilon value. It is plus or minus here. It's minus or plus here. So maybe I should call that minus or plus, since they are linked, you know, which is this one. So yeah, just substitute number 2 with minus or plus. I still call it 2 because it's not related to the other one. Missing semicolon. That's not 0. Definitely not 0. Apparently neither of them. I mean, also the other one is not. Yeah. So it's not a plus or minus thing. Well, that's curious. I mean, it doesn't even matter if I made a mistake in creating this thing, although I don't think I did. See, this is just this thing, which is trivially correct, and I even checked it, I think. So this is C0 and then plus C1 times, and then the D is plus or minus C2 divided by C3, and then times epsilon, plus C2 times the square of this thing, C2 divided by C2 squared, times epsilon squared, and then neglecting this thing. So this equation is the way I want it. I mean, it's still possible that this could not be neglected, but I think it could be, and yeah. Otherwise I just have to pick other variables. But given that this is the equation I want, this should just be the solution of it. So this is the solution to quadratic is minus b. So the plus minus changes into a minus plus, and then C1 times C2 divided by C3, plus or minus the square root of the same thing squared. So that is C1 times C2 divided by C3 all squared, minus 4 times AC, where A is this. So C2 times C2 divided by C3 squared times C naught, and the square root of that, and then everything between parentheses divided by 2a. So that is 2 times this, 2 times C2 divided by C3 squared. Yeah. So if you fill this thing in this equation, this should be 0. Why the hell is it not? Wait a minute. This is wrong. I doubt that makes a difference. So. But of course, we must turn the minus or plus into plus or minus. So this should have been the 2 minus then. And this should be the minus or plus. The way it is. But yeah, I mean, does it make a difference? Does it? No. But this is still going to crash. It is minus or plus times C1 times C2 divided by C3 plus or minus the square root of C1 times C2 divided by C3 all squared minus 4 times C2 times the square of C2 divided by C3 times C0 all divided by 2 times C2 times the square of C2 divided by C3. Why is that not working? Shocked, really. Okay. I don't get it. I don't get it at all. Okay, we're going to write this as a cubic equation, as in a times x. Oh, I'll use epsilon. Epsilon squared plus b times epsilon plus c. So that means that c equals c0, that's the constant. This is times the square, this is times epsilon, yeah. And b equals the coefficient of epsilon, so that would be this part. And a is then the coefficient of the square, so that would be this part. It's really big coefficients, I have to say. And these are even very close to each other. Could it be a round-off error? For very small epsilon? No. With the epsilon close to 1, this would be cancelled out. That shouldn't not happen. Let's check if the expected solutions are really solutions. I keep doing that. Well, these are definitely less than 10 to the power minus 12, aka 0, aka these are really the correct solutions. And I'm using the same formula as I should be using in passing epsilon. So apparently I'm calling it wrong, right? I mean, it's like I'm calling it with this. How is this not the same then? Nothing. Well, this is good. So the A coefficient minus 3.27682 times 10 to the power 7. That appears as 2a here and as the coefficient, and also here. But both b and c are nonsense. I mean, this is c, that should be the constant. What? Why is it looking like that anyway? That looks really wrong. That looks really wrong. And this should be minus b. Well, no, it's not. This is b. Well, this is b. So minus b would be plus that instead of this. I can't believe that this is the correct thing to begin with. So we print this. The last term is yeah, I'm printing a twice. Okay, that's stupidity. So that should be c. So now this is correct, but the b value is still not correct. Plus, I just changed this. I changed this, but this is that's really still, yeah, I do that correctly here. Or the hell did an A appear here? So the B is not correct. The B I have here is this. And that prints the correct solutions. So this B is correct. So we should be using this, where the plus or minus is being the first thing. Should be using this when calling that function, which is here. Okay, what the plus or minus is the minus or plus, because, well, the plus or minus is actually this. 2 minus, the minus or plus. No, that would be the minus b. Sorry, if this is b, then this thing that we add, that we subtract or add the square root of is minus b. So we have to do minus this as the first term there, and that's this. So, and then we have to do minus that, but this is this. So minus this is this, indeed, or this. And that is correct. That is what it says here. Minus or plus 2 times C1 times C2 divided by C3. Plus or minus 1 times the square root of, and then again the square of that is also good. Minus 4 times. Yeah, let's put the C0 up front. Well, it's 4AC, that's why I had it like this. Guess I have to split this one up as well. Double A is no, it is sorry, it's this one. Then the times the square of B minus 4 times A times C. No. And then it worked, so we'll never know what was wrong. We'll never know what was wrong. What? Ah. Ah. Okay, yeah, I'm getting it. And that is the stupidity itself. I have no idea why. I feel so stupid. Unbelievable. Right, so the program was wrong. Okay, I guess the formula is right. Now, still have to make sure that this code is not the same as this formula. So I'm having now a minus, minus or plus. Because because the thing takes plus or minus to check epsilon. But here at least we have minus b, obviously. Plus or minus the square root of the square of minus b, square of b or square of minus b, same thing. Minus 4ac divided by 2a, or that's just the equation. This is correct. And then the minus b is minus or plus. That's why we picked the minus or plus instead of the plus or minus. And then the b is c1 times c2 divided by c3. c1 times c2 divided by c3. c1 times c2 divided by c3 squared. Good. That is b. And that is c0 times 4 times c2 times the square of c2 times c0. Yep, that would be a. And here again, 2 times, that must be the same thing. c2 times c2 divided, yep. So this pretty much corresponds to that now. And it works. So the formula is correct. Let's do the next one. Check epsilon. No, this should not change, I guess. I did not really change anything. But okay, now I want to just do exactly this. Or this did not change, which means that we want to use a minus b, which is now minus or plus 2 times that. Minus b standing for whatever we add to the square root. This. So this whole thing, including the minus or plus. Minus or plus times c1 times c2 divided by c3. Yes, without the brackets now. Without the parentheses. Square root. Okay, so now I have the square of c1 times the square of c2 divided by the square of c3 minus 4 times c0 times the third power of c2. I'm going to type the square c2 times c2. Divided by the square of c3. Two times, and then the same thing, square of c2 times c2 divided by the square of c3. Got my parentheses wrong. Minus or plus times c1 times c2 divided by c3 plus or minus the square root of c1 squared times c2 squared divided by c3 squared minus 4 times c0 times c2 cubed divided by c3 squared. And then parenthesis close is for the square, and another parenthesis close is for that one. So I guess square root is that one. So this one is missing something. Yeah. That work. No, they just jump to the end. Yeah, I don't even use the intermediate stuff, so there's no reason to check everything if it is okay. Something changes with the plus or minus here though. Yeah, I don't know. Maybe check it anyway. So I have something divided by, that's this line, divided by 2 times the cube. I'm gonna introduce a cube here. C3. Minus or plus times C1 times C2 times C3 plus or minus square root, and the square root is then the square of C1 times the square of C2 times the square of C3 minus 4 times C0 times the cube of C2 times the square of C3. Yeah, this one minus or plus times C1 times C2 times C3 plus or minus the square root of C1 squared, C2 squared, C3 squared minus 4 times C0 times C2 cubed times the square of C3, and then divided by 2 times the cube of C2. And that's wrong. I typed the 3 here. 2. Oops. 2. And the rest was correct. I think so. Yeah, okay. Need to write a cube. Werkt. Okay, I'm gonna go straight to this one, right? I mean, still, at least still the minus plus thing here. Minus plus times 0.5 times C1 divided by C2 times C3 divided by C2 plus or minus times C3 divided by C2 times the square root of the square of something minus C0 divided by C2, closing the square, and that's it. No divisions anymore. And the squares of 0.5 times C1 divided by C2. Minus or plus times a half times C1 divided by C2 times C3 divided by C2 plus or minus C3 divided by C2 times the square root of the square of a half times C1 divided by C2 minus C0 divided by C2. You test it and double check it, and still it's not correct. What? No. Why does it change? This changed because for no good reason, it seems. This is just C3 divided by C2 times a half times. Oh, wait a minute. I brought something out of the brackets. Yeah, this part. think this thing is really that thing times that thing. No? Yeah. Well, no, because this thing remains. So I'm really just removing this, bringing that in front together with that one. No, it's the other way around. This is that thing times that, or no, this thing is that thing divided by that, which is the same as multiplying with it. Yeah, so that thing changes. And this is still that, actually. No. This one. No, the square root didn't change. Uh-oh. Mm. minus or plus. Well, it said plus or minus here, but that's what it should be. Times a half times C1 times C3 times the square divided by the square of C2 times 1 plus the minus or plus times plus or minus. That would be this one. Times the square root of 1 minus C0 times C2 divided by the square of C1. And apparently that one is wrong. Let's hope it is wrong. So that means I would have found the problem. Put this in front. And you get, of course, the half and the C1 and the C3 and the C2 and another C2. And then this becomes 1 plus or minus the square root of the same divided by this, but then under the square root. So now we're going to divide by the square of that. And lo and behold, we have a square here. So this becomes 1. And then this has to be divided by that. And the factor half is missing. C0 divided by C1 squared. Yep. Multiplied by C2. So that's 1 and 2. Yeah, the half is missing. So we should have divided by a quarter, aka multiplied by 4. There's a 4 missing there. But I think I had a dimension failure though, so this can't be all of it. This can't be it. That's actually. Nope, that was it. So then if you ask an AI to find the problem, it doesn't see that you miss a 4 here. It just doesn't see it. Worse, it says something else that is complete nonsense. Complete 100% utter nonsense. Useless. Completely useless. But the real error must be below this. Let's propagate 4, however. So 1 plus or minus the square root of 1 minus something. That would be here. Edit. So that must be 4 here. And here. Ah, yes. Yes, actually I see it coming now. Okay, so there's a 4 here, then under the square root, the half changes into a 2. This changes into a 2. And then this changes into a 2. and then this changes into 2. Yeah, well, it used to be 1 minus 4 times, yeah, whatever. Well, 0.2 divided by 1 squared. To write that as 2 times 2 instead of 4. And then we add the square of whatever is between parentheses here, because that can be neglected, because C2 is almost 0, so the square of that is as well. But if you add this, nothing changes. But now we have now we have 1 minus 2 times 1 times something plus that something squared, which is equal to 1 minus that something all squared. And then we can take the square root of that, and then we just get whatever is there. So now we get that, and this is now a 2. So that means that we get minus a half C1 squared times, and then the 1 drops out against the 1, and this half changes into a 2. Equals minus C1, sorry, divided by C1 squared. So it's C0 divided by C1. The 4 drops out here. Unfortunately, we're still not there then, because it should be equal to this. Still have to get rid of the C2. That is, in the limit of C2 goes to 0, it should be this. Now it goes to 0, so yeah. If you get rid of this, then, yeah, I don't know. Maybe there should be a C2 in it still. Or I just work the C2 out maybe by adding this here under the square root. That's a possibility. Pretty sure I propagated to 4 now though. Save. Yeah, it's time to go to bed, unfortunately. So I'm just gonna stop. I'll continue from here tomorrow, because there is more to be found, and of course I can't go without first playing a game of chess. Lord chess. Okay. I really have to win. Interesting. I'm inclined to pin the knight, because then I have my own thread. The thread's not even good enough. If I take here, it takes my queen, take back. Okay, I got a piece, so he has to take back, and then he loses the rook. However, he has the check here, but my bishop is defended, so I can just put a bishop here. Queen has to move again, and then I can still do this, or let's try this. Whoa. Is that so? I'm +2. Oh, he's going to take my knight, is he? Yeah. That is pretty annoying, I have to admit that. What if I develop this, and he takes my bishop, then we're equal. If he takes my knight, I'm gonna win this. So he can't take my knight. So I'm here, and he can't take my knight, right? No, because, yeah. And he has to do something about the fork, and he also can't go here or here, so he has to move the king. And the king can't go here, so the king must go there. Looks pretty equal to me, and he can't castle anymore. I'm just going to do this. Well, maybe unless he would capture my knight. If it's somehow, nah, that's not going to happen. That's not going to happen, is it? Take. Yeah, take. So the pawn here, check. It comes here. And then I take the rook, and then the king could come here. No, they can't because the pawn is here. So I can always escape after that. That's a pretty good move. Could do this. He takes and I castle. He takes check. I need my rook here. Check, castle. Just the rook is there. So a good move. Otherwise the king was blocking the bishop as well. So I do this, he takes there. Now I can't push this, of course, because he just takes here. Weird check, I have to take and he promotes winning a rook. But take a castle. I gave away a pawn for nothing, and he can take the second pawn. That's no good. I have to go here. Oh, I see the light. The king must move or he loses the rook, right? No, he can just move the rook itself. Shit, he moves the rook. The rook can, oh, that's what I miscalculated. I thought the rook could only go here or here, but this pawn is no longer there. He took like that. Plus he can go there. But okay, I have to move this. Let's go here. Oh, no. No. You gotta be kidding me. Trapping my knight. But nice isolated the triple pawn if you take my knight. So he does not. No, I have to take, otherwise, yeah. I lose it. Oh, I can't castle. I need to reuse my rook though, so let's go forward then. I probably should have done that, yeah. To defend this pawn. Yeah, it's gonna take. Of course he's gonna take. That's a pretty bad rook. Oh, he's not taking. Okay, I'm surprised. I'm surprised. Hmm. No time left. Yeah. Yeah, I don't have much, not enough time to think. Should we push this pawn maybe? Chase the knight back. Yeah. No. Yep. No, I lost some time. Okay, I'm gonna go to bed because it's just already way too late. Half past 12 here. I'll be back tomorrow. Good night, people. This thing is on top, so let's move it down. Good here.